So thank you everyone for joining us this evening or this morning, depending on where you are in the world. My name is Bryony and I'll show you through the newest features in our latest release, which is EchoView 12. EchoView 12 was released back in May this year and includes a great collection of new features. We'll work through the list on the screen during this webinar. And of course, there is a lot more in EchoView 12 than I've listed here, and I'll show you where to find more information about this new release at the end of the webinar. So we'll get started by looking at the Calibration Assistant, which we first added in EchoView 11. The Calibration Assistant is a tool to calculate calibration parameters. In EchoView 11, it was compatible with all the narrowband file formats that EchoView supports. And in EchoView 12, we've added support for wideband data. So calibration, our goal is to ensure that we have reliable and quantitative echo sounder measurements. And to revisit the reason why we've got this in EchoView, EchoView makes it easy to have complete control over your data and flexibility in how you tackle the calibration problem. EchoView will allow you to see the data that's being used very easily and to easily correct any problems such as removing noise before calculating corrections. We can also easily perform sensitivity analyses, and I'll talk a little bit about that more shortly. And EchoView's algorithms are fully documented in our help file. EchoView allows you to calculate SA correction and transducer gain for SIMRAD data, or generic SV and TS offsets for all other file formats. Plus, for split beam data, our angle offsets, our beam angles, and we also calculate the RMS error. So in EchoView 12 specifically, we've added support for wideband data. We've also built in a standard sphere calculator. We have some new graphs. We have an exportable report, and the Calibration Assistant is now fully accessible using COM for automation. So let's take a look at these in EchoView itself. I've prepared a SIMRAD EK80 wideband file to use for calibration. And this data is collected from the RV Investigator, courtesy of the CSIRO Marine National Research Facility. So we have EK80 data files, wideband, and the standard variables that have been derived for this data type. In this case, we have 6 frequencies. These variables are visible in our data flow view, and I'm going to focus on the T4 data in this example. So when we're doing calibration, we take our target data, TS data, plus our angular data to give our split beam positions. And we can see in this data set, we've got our calibration sphere visible, what would probably be a weight below the sphere, and lots of targets in the water column. It's quite an interesting data set. So EchoView needs you to first create a single target detection variable in which we identify the targets that we want to work with. We configure our settings so that those targets are available. And we can also set up exclusions to exclude data outside of particular lines or in bad data regions. I've just generated a couple of regions as an example in this file. And so for the sphere targets, we've just created an analysis region to make it really easy to launch the Calibration Assistant for our data of interest, which I'll do now. So to open the Calibration Assistant, we right-click, and for either a selection or a region, the window will be opened. So this is our Calibration Assistant tool. And I won't go into the details of the basics of this. I covered that in our EchoView 11 webinar, which is available on YouTube, but I'll have a look at the new features that we've specifically got available. Starting with our sphere settings. So here we have a built-in sphere calculator, which allows us to automatically determine the expected target strength for a range of typical standard spheres that are used in the frequencies that are of interest to us. And we also have options to define frequency exclusion zones too. So this example has been set up with a tungsten carbide sphere of 38.1 millimeters. And we can see the modelled response that would be expected for this target at these frequencies. If I click the edit button, we can see the options that we have available for our spheres. So in this case, I'm calculating it from parameters. We have options for tungsten carbide, copper, aluminium, or other. For tungsten carbide, we can identify the diameter and the water density. We can also set up exclusion zones. I'll just do a quick example. Let's say from 90 kilohertz until 95 kilohertz. If you just watch the graph in the background as I click apply, we can see EchoView identifies an area that we can choose to exclude from our calibration if we want. Other than calculated from sphere parameters, we can also just enter a single TS value. This would be applicable if you are calibrating narrowband data, and this is effectively the setting that we had available in the previous version of EchoView. We can also enter a TS frequency distribution if we like. So there's a few different options here of what people are most commonly able to do and the ability to customize it. So this is our graph, our sphere calculator showing our expected results. Moving on to the new graphs in the Calibration Assistant. We had a couple of graphs in this assistant in the last release, and we've expanded that further in this release. 4 graphs here, where my mouse is, are our new graphs in this release. So we have a scatter graph, a contour graph, and combinations of scatter and contour. This is a useful tool just as a bit of an overview of your data, and to also make sure that the transducer is performing as you would expect, that there's no immediately obvious problems which might happen if part of the transducer had failed. This colour scheme can be adjusted directly in the Calibration Assistant by right-clicking on the colour scheme. We can change the colours, and we can also adjust the range to make it a little easier to see the variation in this data. And one extra useful feature about these graphs, let me just close this for a minute and zoom in on some data, and then I'll open the assistant again. For the scatter graphs, all of these points you can click on, and the echogram will automatically update to those targets in the background. So if there happened to be a value that looked to be a particular outlier, you can very easily jump to it simply by clicking on a target. So if I click on this, we can see that echogram is moving in the background as we jump to the time where those targets were found. So it just makes it a little bit easier to do your QC process on your data. So, wideband calculations. If I now click calculate for this file that I've set up already, EchoView will calculate our calibration corrections based on the data that I'm analysing here. We can see our results here in the top right. We have dashed line that indicates the current value. So these are the values that are used in the file currently, in which case, because it's a flat line, there are no values set. And we can see our new values below. We've also got our angles, so we can see the current and the new for minor and major axis, for our 3 dB beam angles, and we can also see a graph of the RMS error. Finally, down the bottom, we have our ECS file output. So this is the values that we can just simply copy and paste into our ECS file for our actual survey to use these calibrations. All of this information can be exported to a report, which is just a simple text file. If I click Save Report, EchoView will pop up a dialog that allows me to save this file. Example. And I'll just open this to show you. Okay, example that I just created. Just open this in Notepad, but you can use any text editor that you prefer. So this is the report that we can save. Really useful thing to save if you're running a calibration and maybe you need to come back to this in a couple of years' time and you can't remember what you did. This report will help you understand what's happened to calculate these calibration corrections. We just have some basic information about what was used to create it and when, our output values that were calculated, the input values that were used for those calculations, our settings relating to our target detection and our data, the settings for the sphere itself, our corrections, summaries about the targets, and at the very bottom we have again that same ECS file output. So really useful to potentially store alongside your data or your EV files as that really good clear record of what was used to calculate the corrections. The final thing about Calibration Assistant that I'll show today is there's COM access to all of these settings in this window now. That means that you can automate all of your calibration if you like, which would be particularly useful if you wanted to perform a sensitivity analysis. So for example, if you wanted to understand the implications of changing your off-axis angle by, say, 0.1 degree at a time, you can very easily automate that by changing the value, calculating, changing the value, calculating. Useful for other purposes as well, but particularly sensitivity analysis. So that's all I'll show for the Calibration Assistant. Moving on just to discuss performance and responsiveness in EchoView 12. Here at EchoView, we are completely committed to constantly improving EchoView's performance and responsiveness to make it a better and more enjoyable experience, especially when people are working with greater volumes of data all the time. So in terms of responsiveness, EchoView now allows you to do a lot more while heavy calculations are being performed. So in previous versions, you might be familiar with seeing EchoView's interface kind of lock up a little bit, not allowing you to do anything until calculations have finished. In EchoView 12, a lot more of the time, that won't happen. So you can change settings while echograms are being calculated. And you also have the ability to cancel analysis exports. That's shown on the screen. It's just a really useful thing to do if you accidentally start your export for a really large file and realize there was one thing you forgot to do. You can click cancel now. Previous versions of EchoView, that wasn't possible. So this is currently done for analysis exports, and in future versions of EchoView, we'll extend this to other types of exports as well. For performance, EchoView we've made some great improvements into the speed of reading data files and deriving raw variables. Also recalculations. So if you're adjusting settings that are related to calibration or platforms or transducers or GPS data, EchoView will recalculate and react to those changes much more quickly. We have more virtual variables that have been multi-threaded in EchoView 12, and we've also multi-threaded virtual lines. And if you commonly use the best bottom candidate line pick operator, this is one of those, and it will calculate much more quickly now and not lock up EchoView while it is calculating, which is great news. And for those of us that have very complicated data flow processes set up, EchoView will be a bit faster when you're moving around and working in that complicated data flow window. For performance, as always, the computer hardware that you're using is key. It's very important, especially if you're working with large volumes of data, to have a good computer. So that means a very fast CPU, lots of RAM, and also to have the data stored in a location that is quite fast for read and write speeds. These three factors are the most important for getting good performance out of EchoView. The next topic that I'll talk about is the multi-beam school detection algorithm update. EchoView offers several different algorithms to detect schools in multi-beam data, and one of these is called the cruise scanning algorithm. And this algorithm is designed to detect schools from a vessel using multi-beam data, so a moving platform. And jump to EchoView for a demonstration to understand what the problem was previous versions of EchoView and how we've improved that. So what I've got here is some Teledyne Reson data. And this particular data is kindly shared by Monterey Bay Aquarium Research Institute. This data is collected, it's about 200 meters range of data with very high resolution samples. And if we zoom in, we can see there's some strong backscatter at about 57 meters range. And if I scroll through the pings, you can see that a few school objects come and go. A few areas of high backscatter come and go. So there's a really clear, solid aggregation of something in the water here, which looks to be a really great candidate for school detection in multibeam data. And the problem occurs if we look at this same data in our 4D window. So for a multibeam data, you can right-click to launch 4D window. And this shows our multibeam data in georeference space. So these are all the individual samples that we can see. And if I move around, we can see these are our echograms. We can show a few different pings at once, and I'll just scroll forward to that particular school of interest, which is around here. There we go. In this echogram, if I change my display thresholds, we can see it's a great cluster of samples here that I'd love to detect as a 3D object and explore the shape and size and volume of that object. But if we have a look at these pings from above, what you can see is the slight movement, change of heading or bearing of the platform as the data is being collected means that these pings intersect or overlap each other. And this is the challenge for EchoView in the older versions, where if these pings intersected, EchoView would ignore the entire ping that intersects. And as a result, any schools that we detect from this data would have some odd artifacts. So if you think about what we just saw for the georeference samples, this is our detection result from EchoView 11, and it's not very good. I wouldn't be analysing this happily. In EchoView 12, updated our algorithm, and it now better considers overlapping pings. And instead of ignoring the entire ping if it overlaps, we just ignore the samples that overlap. So here in the blue, we can see a much better 3D object has been detected from this data. This is actually far more representative of real life, and I'd be happy to start looking at this from a 3D volume perspective. So for those of you working with multi-beam data and interested in 3D schools, EchoView 12 has got some really great updates for the situations when pings might overlap. Next up, I'm going to talk about Nortec Signature Echo Sounder support. So Nortec have recently released some new systems, profilers, that combine ADCP and echo sounders in the one package. And EchoView has added support for the echo sounder data from these systems. Let's take a look at some data in EchoView. So this data was kindly shared by NOAA's Antarctic Ecosystem Research Division. This Nortec data file format, which has an AD2CP extension, EchoView will read this and derive a number of raw variables. In this particular case, the system was set up to have 70 kilohertz narrowband data collection, 120 kilohertz narrowband data. For both of these frequencies, we have power, SV, and TS echograms available. And the same system can also collect wideband data. We don't yet read the wideband data as the original chirp or complex data, but we do read Nortec's pulse compressed variables So this is wideband data that's had a bandpass filter applied across 5 frequency ranges, and we provide that pulse compressed data. So there's no wideband complex information behind this, it's just the pulse compressed values. So if we take a look at one of them, which is 91 kilohertz center frequency, this is the data. This was a bottom mounted system looking upwards towards the surface. So the transducer face is at the bottom of this echogram, and this is the water surface here. We can see there's some really interesting layers in the water column and some nice clear targets close to the transducer face as well. Some really good targets. If I zoom back out, we can see we get to have a really nice, interesting overview of the patterns in the backscatter of the biomass across time. So these grid lines are highlighting every 6 hours. For NORTEC data, we have been collaborating with NORTEC and some other co-authors to do a performance evaluation of a combined ADCP echosounder system. This is the NORTEC Signature Profiler. This paper will be published as part of the Oceans Conference, which is in September this year. So this is a bit of a preview for a paper that is coming and a presentation at that conference. And basically we took the ADCP data and the echosounder data and just had a look at what we could see in this data for a 4-month deployment. This deployment was from a bottom-mounted mooring in the Mediterranean Sea, and it gave us some really fascinating insights and views of temporal or seasonal patterns at a really long time scale, so from different seasons, and it was really easy to see the daily migration patterns in this particular data set. Very interesting data, and I look forward to sharing this more after this conference has occurred. Next, I'm going to have a look at mouse pointer duplication. This is just a simple tool that makes it a lot easier to cross-reference data that you have open in EchoView, which could get a bit confusing, especially if you've got a lot of windows visible. Let's have a look at that in EchoView. So in this case, I've got some ME70 data, multi-beam system again, where we've got our multi-beam ping, we've got our single beam data and several graphs and our cruise track open as well. Mouse pointer duplication is toggled on or off using this tool. If you can see at the top of the screen, mouse pointer duplication, we can turn it off or on. And when it's on, you'll see cursors or icons on all the windows that have overlapping depth or time. So if I move my mouse up and down in the multi-beam echogram in the middle, we can see that there's a little cursor on the bottom right in the echogram. This is indicating the same depth. We can also see for my ping graph on the left that there's a horizontal dashed line that's moving up and down at the same time as my mouse. Likewise, if I go to my single beam version of the echogram and I move right and left, we can see our GPS indicator is updating and our line data is also updating with the time. So just a useful little tool to cross-reference our data. And this works across almost all of the windows in EchoView. We've also made some changes to graphs to make them a little bit more useful in terms of properties so that we can identify our settings and lock settings down, as well as synchronization of graphs. If I go back to this same EV file, if we have a look at this graph, this is our ping graph. By default, that will show us the entire range of our data. But maybe in this case, we're interested in only looking at the bottom at backscatter, which is around about 28 meters in this file. I'd like to synchronize and look at this at the same time as my data. But if I start synchronizing and zooming in and out on my echogram, the graph will stay in sync with our echogram, which is great, but maybe we want to just focus only on that bottom depth. I can do that by going into my graph window, right-click, and we'll see this new option here, which is Graph Properties. Also has a shortcut key, but if I click that, I can fix the extent of my graph. So maybe I want to look only between 27 and 32 meters. That graph updates and sticks with that particular y-axis range. If I zoom out on my echogram and look at different parts of the data, my pin graph stays updated no matter what I change with my zoom level here with part of the data that I'm really interested in seeing. We can go back to Graph Properties and easily clear that. This is also useful for other types of data, including regular single beam, narrowband, and also imaging sonar data. In this case, I've got some DIDSON imaging sonar data, which some people may be familiar with. It's basically an imaging camera. We get to see fish quite clearly in this data, which is pretty neat. Echoview has tools to automatically detect fish as targets in this type of data. And targets that have been detected can be converted to a standard depth versus time view echogram. So I've detected these targets, and in this file I've also set up fish track regions to identify the targets that I believe belongs to the same fish across time. One of the changes relating to synchronization is a new option called Sync to Target. If we zoom in very close to these targets and press A to synchronize, we get the same point in time, but we don't actually see the target because there is an associated angle for these targets. So to get around that, if I click on a target, right-click on a target and choose Synchronize to Target, that synchronize will be updated in these multi-beam windows to jump to the particular beam angle that any target is found in. So this is really useful if you're reviewing the quality of your multi-beam target detections. And in terms of reviewing this data, we have a variety of graphs in Echoview, particularly for single targets. If I graph this region and look at 2D projections, this will launch 4 different graphs that we might use to explore these different tracks and ensure that we think these tracks are good quality. And we usually do that by clicking on our fish track regions and seeing the results update. And similarly to before, it's a bit hard to compare when these scales are changing, different selections or regions. So again, this would be another example of a time that it would be useful to lock some minimum and maximum values so that when we're comparing, we get a better understanding of the differences between these tracks. Echoview has a lot of tools for synchronization, and they're really useful to use regularly just to make it easier to understand your data. And then a segue related topic for synchronization. This leads me nicely to the new capability to synchronize shipboard acoustics with towed camera data. So Echoview allows you to define the relative location of videos that were recorded on a towed body that might be a trawl camera so that they can be correctly synchronized with shipboard acoustics, and makes it really easy for you to compare echo sounder and camera data for the same volume of water. Echoview needs information about the depth of the camera and how far behind the boat the camera is, plus the vessel speed, and it will automatically calculate the relative position of the trawl camera to your transducer. So we'll have a look at a demonstration of this using some data that was collected by the Institute of Marine Research in Norway. They're using a deep vision system. The Scantrol deep vision system is a subsea vision system that attaches to a trawl that can be used to help with identifying and measuring fish that are passing into the net. And the system will capture stereo images. And for EchoView, we take images from one of those cameras and convert them into a video, which just improves performance. And then we can look at all of that data alongside our acoustic data. So let's have a look at that. Okay. Just arrange these windows. So what we have here, we have quite clearly some video data. This has just been added to our file set as a video with some associated information that helps EchoView understand the time of the video. We can see our fish passing through into the net. I've got some EK60 data, and I've got GPS information that locates this data. And I've got two particular metrics about the towed camera. So the first is length. So this is the distance from the vessel to the trawl camera, the length of the line. I actually don't have the correct measurements for this data set, so I've just made up some values, but you could have this information, or you could set a generic distance. I've also got the true depth of this particular data set that's been extracted from the deep vision recordings, so we know how deep in the water column it is. For our video data, we now have some extra settings in variable properties. And this tells us the tow point of this video. So this is just an offset relative to your platform reference point. We have our tow line. So this is the length. As you can see, I've used these values that are shown in this graph here. Alternatively, you could use a fixed length for an approximated distance. And then we've got the depth of the system, where I've used this information here. And you also, again, have the option to use a nominal depth if you don't have exact measurements. So this helps EchoView to understand where that video is in time, and therefore translating to the same volume of water. On the echogram here, I've got a red line displayed, and this red line has been automatically calculated from these inputs. So this line is called the tow body time offset operator, which takes acoustic data as operand 1, depth data as operand 2, and then we can identify the length. And this line has been recalculated from these three inputs to give us an indication of where, during the survey, where the camera was at any point in time for the same volume of water. So we can synchronize these windows. I've got my auto-synchronize indicator here that I can click and drag and have a look at what fish were were passing through the net at that time. Yeah, so this gives a nice, easy way to look at these sorts of measurements where we've got camera on a remote platform plus acoustics on a ship, and just to synchronize all of this in time and space. Quite a neat technology that's getting a lot of interest. Final little topic that I'll cover during this webinar are licensing updates. So for people with licenses, you'll be familiar with our modules, which are shown in this diagram on screen. We've just made a few little changes to this in EchoView 12, mostly around language, to help it be a little easier to understand what might be useful for your particular application. One of the more noticeable changes is that we no longer have a media module. The media module in older versions of EchoView was used to license the synchronization of video and image data with acoustics. There's no longer a specific module required for that. That's just available to everybody now. We've also renamed EchoView Essentials to Essentials. Essentials is the core component of what we call the analysis suite. So most of our users who need to analyse data can access the full power of EchoView with the analysis suite, starting with the Essentials module and adding other modules on top of that, depending on the applications and their needs. Some users are interested in just collecting, visualizing, and cataloging data, and they're not performing any calculations. And so what was previously live viewing module, we now refer to as Survey Suite. And this includes the ability to both live view data in real time and also review data after a survey using both EchoView and Echo Explore, which is our catalog software and included as part of this package. So it's an entry-level option for those that don't want to perform calculations but want to review data. And finally, habitat classification stays the same. This is a specialist package that allows you to analyse underwater vegetation and classify the bottom in single beam data. You might see these terms appearing more in your communications with EchoView. Hopefully this just helps you to understand the relationship of the old and new. As I mentioned, EchoView 12 has a lot of other new features, and our help file is the place to visit to read the full list of changes in every new release, both general and changes that are specific to certain Echo Sounder makes and models. Every release, I thoroughly encourage you to read this, look at the new changes, and make the most of the new features that are available in a new version. And if you ever have any questions on how to use a new feature, send an email through to our support team and we'll do our best to help you out. The latest version can always be accessed using the EchoView software updater or downloaded from our website. When you go to the updater, EchoView will give you the option to see the release notes. Our release notes will give you an overview of the major new features in a release, but also, more importantly, the specific changes that have occurred since we initially released a new version. So we can see, since we released EchoView 12, we've released 2 minor updates, and these include some bug fixes that fix some problems in certain situations and a few improvements and other small adjustments. The updater can be opened from our Help menu and by clicking Check for Updates. And I encourage you to do this and make sure, if you're using EchoView 12, to use the very latest version at all times, just to get the best experience. That comes to the end of the webinar. Thank you very much for listening and seeing these new features. If you have any questions, please feel free to put them in the chat box now or to send an email after the webinar. We also love to hear any ideas or requests for new features in future versions of EchoView, so please feel free to send them through. We're now working on our next release, which will be EchoView 13, and really excited to bring you another great version when that's completed. But otherwise, thank you very much for your time, and I'm happy to take questions if you have any.